Assalamu alaikum. Welcome to another lecture on power generation techniques. Today we will be covering diesel electric power stations and nuclear power stations um, along with gas turbine power stations. We are going to try and conclude these power generation techniques in this lecture. I hope you are ready to move on. So in a diesel electric power station, we use a diesel engine as a prime mover. We feed diesel to this engine uh, and this fuel runs the engine and the shaft of the engine, which is coupled to the generator shaft, which generates the electricity. So as I have told you previously that diesel fuel is burnt in the engine to produce mechanical force. By mechanical force we mean the rotation of the shaft of the engine. So the engine will drive the alternator, and that alternator or generator will produce the electricity. So the major concern in these plants is that the cost of diesel fuel is high, and that makes the electricity which is generated by these plants expensive. And we cannot afford expensive electricity generation. Yeah, and that is especially true if we have options like hydroelectric power, which is a very cheap source of electricity production. So such diesel electric power stations are only used for low power generation. They are used as standby power plants to provide power to certain areas of importance in the event of a blackout. Or they can be used to produce power for main power generation equipment of any big hydroelectric power plant or steam power plant. They can be a standby power plants for those power plants. Um, the advantages of diesel power plants include their design and layout, which is quite simple. Uh, Although the layout might not be that simple, but the parts are easily available, and numerous people are available to, and the expertise in this field is also readily available. So there is no problem in setting up a diesel electric power plant in a very short amount of time. The space requirements are very low, and this is because only we have a very small number and size of auxiliaries which are needed. Obviously, by auxiliaries I mean the equipment which is used to support the main objective of producing electric power from this power plant. So the startup is obviously very quick for diesel electric power stations. It can you can just start it with a button, and then it will be able to produce electricity within say 5 minutes. And it can pick up load in a very short amount of time. So there will be a slight warm up time for the diesel engine, and after that you can connect it with the grid and pick up the load. The cooling water requirements are very less as compared to other plants. For example, its cooling water requirements are less as compared to nuclear power plants or steam power or coal-fired power plants. Operating personnel requirement is also very low because obviously you do not need many people to operate this power plant. It only needs to be all control is automatic, and the plant is started by the press of a button, so it's a very simple startup. So you do not need many operating personnel to operate this power plant. The disadvantages of this plant obviously is number one, high cost of fuel, as I have already told you. The generation of power from this power plant is quite small, and then lubrication and maintenance requirements are high, and lubricant oil are also is also very expensive. So these are some of the disadvantages of this scheme. Before we move on, let us delve into the working of a diesel engine. So a diesel engine, as shown in the figure here, it is a in this engine we have a couple of components, and the most pronounced of these components is the pistons and a chamber in which the diesel and air, a mixture of diesel and air is present. And then there are some intake valves and outlet valves, and then there is a fuel injector which injects the fuel, which mixes with the air. So let us look at the working of this diesel engine. So the first diagram is showing you the first stroke of a diesel engine, which is stroke is any pronounced movement of pistons. By pronounced movement, it is a movement which produces any significant action of the diesel engine. So in the first stroke, which is also called the intake stroke, the piston moves downward. Its piston moves downward, and air is allowed inside the cylinder via the inlet valve. You can see here we have inlet valve. The air is allowed to enter the chamber via this inlet valve as the piston moves downward. In the second stroke, which is also called the compression stroke, due to the inertia of this rotating mass, the rotating mass pushes the piston upward into the cylinder, which causes the air which is contained in this chamber to be compressed. As the air is compressed, its pressure increases, and as this air is not allowed to leave this cylinder because the inlet valve has closed, so its temperature will rise up to a very high value, and we need to increase this temperature to a value above 52 degrees Celsius, which is the flash point of diesel. By flash point of diesel, I mean that above this temperature, the diesel is able to burn at even without any source of flash, without any ignition source. So the air is compressed to the ratios as high as 70:1, or 17:1, or 24, or even 24:1, which means that the pressure of the air inside the chamber is 24 times higher than the atmospheric pressure. So this makes raises the temperature of this air to above the flash point of the diesel. So in the third stroke, which is also called the power stroke, as the piston which starts when the fuel injector injects a diesel as atomized droplets into this chamber, in which air is contained at a temperature which is higher than the flash point of the diesel. As soon as the diesel enters in this chamber and mixes with the air, it ignites because the temperature of the air inside chamber is above the flash point of diesel. This causes the piston, this forces the piston to move outward, and this is called the power stroke because this explosion causes rapid expansion, which generates power, and this power rotates this crankshaft, and then it rotates as the piston moves downward. So this is the third stroke. It is also called the power stroke, as all the power which is generated by diesel is present inside that stroke. And then due to the inertia of the crankshaft in the fourth stroke, which is also called the exhaust stroke, the piston moves upward again, and at the same time the exhaust valve is opened, so all of the byproducts of the combustion are expelled from the chamber during this stroke, and then the first stroke is happening again. So out of all these four strokes, only third stroke is the one which is generating the necessary power to carry out all the other strokes as well. So you might ask, what will happen when the diesel engine is not started? What is generating power for that diesel engine then? So we are going to delve into that in some details later on. So the number one thing you should note about this diesel engine as compared to a petrol engine, there are no spark plugs present inside a diesel engine. So this is the major difference between diesel engine and petrol or gasoline engines. So there are no spark plugs inside a diesel engine. The power is produced when the diesel is ignited due to the temperature of air inside the chamber being above the flash point of diesel. So in gasoline engines, the combustion is timed. So in the gasoline engine, there are some certain timing belts or timing circuits which time the ignition of the fuel which is present inside the chamber, and that fuel is the mixture of air and with gasoline. So that optimizes the power output of the gasoline engine, and obviously because the combustion is timed, it is not spontaneous, so we can control and coordinate the combustion, which will result in lower engine vibrations in the engine. And therefore you can see that the diesel engines are made of similar capacity are heavier than the corresponding petrol engine, because in them the combustion is not timed, it is spontaneous, and we have to contain the vibrations, and we have to ensure that there is enough mechanical strength in that engine to contain those vibrations, to lower those vibrations, and to increase the service life of the engine. So normally diesel engines are bulkier than the corresponding gasoline engines. So spontaneous combustion in diesel engine can cause vibration and added mechanical thermal stresses, obviously, and this necessitates the construction of heavier frames compared to the gasoline engines, which I have already told you. That is why the diesel engines are heavier than gasoline engines. Let us talk about some components of a diesel engine, this diesel electric power system. And in this power system, we have a fuel supply system, which consists of storage tank, which stores the diesel in the site of the plant, so that we can produce power from diesel for say a month or two. Uh, and this fuel is stored in this tank in order to avoid any reliability issues of the plant. Say when you need to run the plant and you do not have diesel, then you cannot run the plant, so we create storage and store our fuel in that place, so that we do not have to rely on outside sources to provide us fuel. Then there are strainers. Obviously, their strainers and filters are there to because the stored diesel is not exactly clean, so you have to ensure that they are not suspended for impurities in it. So you use strainers for that purpose. Fuel transfer pump is also a part of fuel supply system, which will transfer the fuel from this fuel storage tank to a all day fuel, fuel tank or day tank, which is it is called day tank as well. So at the start of every new day, if you are required to run the diesel power plant, the fuel from storage tank is supplied to the day tank via strainers, and then from day tank it is injected into the diesel engines. Then there is an air intake system. Obviously, we need air to perform combustion. So filters are present in that air intake system, which remove dust particles from the air, fresh air, before it is injected into the engine manifold. So engine manifold is just a pipe which has one opening from where the air is injected, but it has multiple openings for different chambers of the engines, so that air can enter these chambers simultaneously. So then there is an exhaust system. Obviously, you need an exhaust system to allow the byproducts and gases to escape, and they are discharged into the atmosphere via silencer and muffler. And silencer and mufflers are the equipments which reduce the noise level inside the plant, and they are also responsible for reducing the vibrations in the plant floor, and they are very important in that sense. Then obviously we need cooling system, and then we have for that we have water source from which we draw the water, and then we pump that water into the engine jacket, and then though that water removes excess heat from the engine walls, so that they do not get damaged at high temperature. And then the hot water is pumped into cooling towers, which are used to reduce the temperature of that water and pump it back again to the engine jacket. After this, we have a lubricating system, which consists of a lubricating oil tank, and lubricating oil is present inside this tank. Then there is a pump, which it is not written here, but there is also an auxiliary pump. In case this pump fails, the auxiliary pump continues the flow of lubricating oil through the engine, so that engine does not get damaged. And then there is a filter and oil cooler, which cools the lubricating oil which has flown through the engine. It cools that oil cooler cools that oil, and filter is there to obviously remove any impurities in the oil. We have an engine starting system, which is an arrangement to rotate engine shaft initially before firing takes place, and engine runs it on its own power. So we know that power stroke in a diesel engine generates power for rotation of crankshaft and therefore performing the other strokes. Over here we can see that we need an initial outside source of mechanical power which can rotate the shaft of the engine so that the first two strokes can happen, and then in the third stroke power can be generated, and then the diesel can sustain its rotations itself. But before the third stroke happens, for the first two strokes we have to rotate the shaft of the engine, and in smaller units we can rotate it by hand using hand cranks. But in large units we have compressed air motors for starting these engines. We will discuss them shortly as well. So compressed air motors are the principle of using compressed air motors is described here. So compressed air is admitted into few of the cylinders. Like there are many cylinders in a diesel engine. So in few of these cylinders we admit compressed air to make them run like reciprocating air motors. So what happens is this compressed air enters the chamber, certain cylinders of the engine, and it pushes this air compressed air pushes on the pistons of those cylinders. And those pistons, obviously all of the pistons of the engine are coupled to each other via the crankshaft. So if you rotate some of the if you move some of the pistons of some of the cylinders, you are also going to rotate the crankshaft, and the other pistons are going to rotate as well, are going to move as well. So fuel is admitted to the remaining cylinders for ignition, and when the ignition happens, then the process sustains by itself. So these 2 points explain how this happens. So compressed air is going into some cylinders, and they push the piston of those cylinders down. Now those pistons move down, but they come up because of their own because of the inertia of the crankshaft. So when they come up, they compress the air, and the predefined time when the compressed air is maximum, when air is compressed to its maximum limit, then the diesel is injected via the fuel valves, and it ignites because the temperature of the compressed air is above the flash point of the diesel. So this is how starting takes place.